So we have an acute angle. We have an acute angle of 72 degrees, this angle here. I'm thinking of SOHCAHTOA. What ratio will I use, tangent, sine, or cosine? Well, that depends on what they gave us. What side is this in relation to the angle? Adjacent. So it's either going to be tangent or cosine. Let's see what the other side is now. How about this one? Opposite and adjacent, so we're going to use tangent again. Notice how I did that. I look at the sides they gave us, and depending on what they gave us, that's the ratio I use, sine, cosine, and tangent. So let's do tangent again. Here we go. Tangent of the angle. Remember, that's some eternal number that doesn't change. Is equal to the opposite of 72 is x over 20. We did a lot of these the other day. We could do this in our sleep at this point. Let's get x by itself. Let's multiply both sides by 20, because that gets rid of the 20 denominator. Punch this crap in your calculator. Round to the nearest tenth. Help, somebody. 2.6? One more time? 61.6 sounds good to me. Yeah? We're good, Medina?
Yeah, I put 8 for some reason.
Okay. It's going to be okay. Here we go. Any question on number 2? Let's try number 3. Copy this one down. Copy number 3 down, please. Yeah, let me go back. Well, we got x by itself.
Can you explain how the x is on top, x is on bottom?
Sure. Well, because the tangent ratio, remember, look at tangent ratio means opposite over adjacent, huh? So the opposite of 72 is x. That's why x is on top. The one you did was, look at, what was opposite? It was, opposite of 46 was actually 7. So 7 was on top, x was at the bottom. It's adjacent. You see that? Good. Good question. We're done here.
So whatever's opposite goes on top?
Right. It's in this order. It's in SOHCAHTOA order. This tells you the whole thing you need to know. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent opposite over adjacent. Just a memory device. That's all that word is. Now, let's do number 3 now. Here we go. Number 3. Copy it down, please. I'll give you a minute to copy this down. You with me, Rocha? Just checking. After this, I'm going to have you do that. Remember the square root, breaking down the square roots that Mr. Esquivel was helping you on? We're going to finish that assignment after this, okay? I'm going to have you catch up. I got a game plan for you. All right. All right, the acute angle I'm dealing with is 54 degrees right here. I'm thinking SOHCAHTOA. What sides are given Leviera? What side is given here? Adjacent is for sure given. What's this side now? And hypotenuse. So I'm looking at the SOHCAHTOA. Which one has adjacent hypotenuse? Cosine. That's what I'm going to use. Cosine. Here we go. Let's set up the equation now. Cosine 54, look at that. I'm abbreviating. Is adjacent is x. Hypotenuse is 12. We're rocking and rolling. Simple as that. Let's get x by itself. We'll multiply both sides by 12. So to the nearest tenth, x is approximately, somebody type that for me? 7.1. We're rocking and rolling. You guys are trig masters already. All right. Questions before I go on number 4? Okay, wait, let's go Medina first and Rios. Go ahead, Medina. Okay, so look at the acute angle. And now we ask ourselves, what sides did they give us? Well, look at x is adjacent. That's an A. Real quick, that's an A. And then this side is opposite 90. That's your hypotenuse. So out of the three ratios of SOHCAHTOA, which one has adjacent hypotenuse? Cosine does. Tell you what, just stay with me for now, and I'll show you the button sequence after this. Unless you have better ideas, Miss Medina. I mean, I'm willing to help you. Are you frustrated with that, or? Never mind. Jeez. Number 4, let's do it. Going to copy this one down. Number 4. You with me? All right. All right. Garcia, what's the acute angle they dealt us here? Beautiful. Franco, give me one side they gave us. Adjacent, opposite, hypotenuse, what did they give us? They gave us a hypotenuse, it's opposite 90, so I know I got an H. Aguiad, what's another side they gave us beside the hypotenuse? X, huh? So what side is this in relation to 40? What side is this in relation to 40? Is it adjacent, hypotenuse, or opposite? So this is adjacent to 40? So what side is this in relation to 40? Forget the ratio right now. What side is this? Opposite. So I'm dealing with O and H, huh? So we're dealing with sine. Think SOHCAHTOA, we're dealing with sine ratio. So coming back over here, let's set the equation up. Sine, sin, short for sine, 40 degrees as your angle. Remember, that's some eternal number that your computer knows. It doesn't never changes, no matter how big or small the right triangle is equal to opposite over hypotenuse. Opposite of 40 is x. Hypotenuse is 19. We're rocking and rolling. You should start seeing the ease of this now. The hardest part is just figuring out sine, cosine, or tangent, which one you're going to use based on the sides they gave us. The rest is just getting x by itself. So let's get x by itself. We're going to multiply both sides by 19. That gets rid of the 19. X is alone. Beautiful. That's what we want. To the nearest tenth, anybody? Awesome. And we're solving for missing sides of right triangles without using Pythagorean theorem now. That's the beauty of all this. This trigonometry is the basis of GPS systems. It's the basis of all kinds of engineering systems, weapon systems, ICBM missiles. The reason why we can taunt North Korea and put pressure on them to put their ICBM missiles away is because we have defense systems that if they gave us an ICBM nuclear bomb, we can intercept it using trigonometry. But highly, highly complex trigonometry, approaching calculus trigonometry. But nevertheless, what we're doing is the foundation for a lot of engineering, just a little FYI. Any questions on number 4? Last one. Number 5. Again, we're not taking notes today. This is an extended warm-up, a review of yesterday's learning. Last one right here, Ariola. Medina, are you giving up on me already? That was like record time. I got you. I got you. Watch this. There he is. Boo Yankees. Come on. Uh-oh. Uh-oh. Gonzalez, we miss you, man. I got you. Hold up. So, like, say. Go, Gonzalez. Watch this. 6, 10. What the heck? What is this coming up? You know what? Let's review. Okay, watch this. 6. Yikes. That's pretty nasty. try it again. Okay. Okay. 6 tangent, let's say 40. Hit equal. Is this working? Let's try it right. Let's try it again. Watch. Watch. It's all right. Here we go. Esquivel, what's the acute angle, please? 31. Sevilla, what side would x be in relation to 31? Opposite, adjacent, or hypotenuse? Nice. So we're dealing with opposite. And what would this one be, Mr. Gonzalez, in relation to 31? What's this side? Nice. So opposite and adjacent. Which one? Tangent. We're rocking and rolling. So stay with me, Medina. You're going to try this one now. Tangent of 31 is opposite over adjacent. Let's get x by itself. What do we do, Garcia, to both sides? Nice. So Medina, do this for me. 10 tangent 31 to the nearest tenth. Hit it, Ariola. What I got? Everybody agree? Beautiful. Beautiful.